What we're going to do in this video is evaluate this pretty hairy expression. And we could just try to do it. We could go from left to right. But it feels like there might be a simpler way to do it. I'm adding 13 here, and then I'm subtracting 13. I have a -5 here, and then I have a +5. You might be tempted to say, well, maybe I could change the order of that I'm adding and subtracting things. Well, if we were just adding a bunch of numbers, you could change the order. For example, we know that 9 plus 7 is equal to 16. And if I just change the order, the commutative property tells us, well, 7 plus 9, it applies to addition. If I swap the order here, it's still going to be equal to 16. But that's not true if I do 9 minus 7 or 7 minus 9. If I change the order, I'm not getting the same result. The commutative property does not apply to subtraction. This top expression is +2. This bottom expression is -2. So I can't just use the commutative property here to change the order with which I am adding and subtracting because I have subtraction here. But what if I could rewrite this expression so it only involves addition? How can you do that, Sal? You are probably thinking. And the key realization is when you subtract a number, it's the same thing as adding the opposite. For example, if I have 6 minus 3, that is the same thing as adding the opposite of +3, which is -3. Or if I had 6 minus -3, subtracting a number is the same thing as adding its opposite. So what I could do is all of these places where I'm subtracting a number, instead I could just rewrite it so I'm adding the opposite. So let me do that. So I can rewrite this expression as -5 plus 13. So far I'm only adding. Here I'm subtracting all of a sudden. Minus 21. Subtracting a number, well, I can rewrite that as adding its opposite. So subtracting, let me just another color. Subtracting a number is the same thing as adding its opposite. All right, let me keep going. Then I'm adding a 5. Remember, I'm just trying to make this so I'm just adding a bunch of things instead of adding and subtracting. I have the plus 21. Now again, I am subtracting a number, so I can rewrite that as adding. I'm subtracting a +13. I can rewrite that as adding a -13. And then, last but not least, over here, I am subtracting again. I am subtracting a number, so I can rewrite that as adding the opposite of this number. So I'm now adding +11. Subtracting -11 is the same thing as adding +11. Now, why did I do this? Well, now I can use a commutative property. All I'm doing is I'm adding a bunch of numbers now, so I can swap the order with which I add. So I could now rewrite it. Let's see, I have a -5. And now let me add this +5 next. So add the +5. And then I'm adding a +13. And to that, I can add the -13. Remember, the only reason why I can now swap the order is because I'm only adding a bunch of integers. Next, I have this -21. So let me circle that. I'm adding a -21, adding -21. And then I could add the +21, which is right over there. And then last but not least, I add 11. Now, why was all of this super useful? Well, now look what happens. Things start to simplify a lot. Not only when I'm doing addition can I use a commutative property, can I change the order, but I can also use the associative property very easily. So I could start to say, all right, let me add these two first. And I could also add these two. I can pair these up. And that's useful because these cancel out with each other. They're opposites. If I take a -5 plus a +5, that's a 0. A 13 plus a -13, that's a 0. A -21 plus 21, that's a 0. And so what am I left with? I am just left with a +11. So hopefully you see that if I can rewrite subtraction as adding the opposite, I can now use the commutative and the associative properties to really simplify things, which is really useful the rest of your mathematical careers. I encourage you in your own time, go left to right with this original expression, and you'll see that you get this exact same result. It's just going to actually take you a lot more time.